Hello, good evening fans. I am Deepak again welcoming you at the Personal Tutor, and here today I will discuss the laser semiconductors. So in this topic I will cover the various types of the laser, such as the semiconductors laser, gas laser and the solid states laser. So as I talk in the previous lecture, I discussed about the how the some optical sources works. In the previous lecture I discussed about the light emitting diode and the laser, and here I'm again going with the laser action. This is very important topic for the people who are working on the optical communication. So shall start. Laser stand for the light amplification by stimulated emission of the radiation. Light amplification by stimulated emission of radiation. What the meaning of the stimulated emission? So in this topic we'll understand what is the basic difference between the light emitting diode and the laser. What is the spontaneous emission and what is the stimulated emission? So here I'm going to cover firstly the laser action. So again I'm making a diagram. This is diagram A, this is diagram B. This is the ground state E1, this is the another state E2, same, it is the lower energy state E1 and the high energy state E2, and there is the intermediate state which is called the E3. Now we have in this topic we have to remember the following terminologies. The first one is the absorption, second stimulated emission, third is the pumping energy, fourth is the population inversion. These are the terminologies: absorption, stimulated emission, pumping energy and the population inversion. Now I'm going with the one by one steps. Sorry. As we all know, electrons rotates in the orbits of an atom. And as we know, according to Bohr's atomic model, every atom consists of many orbits. The outermost shell or the outermost orbit of an atom is called the valence band or the outermost shell. If I am taking the example of the semiconductors, such as the silicon and germanium. So its the valence electrons are the 4. Let's start. Suppose my electron is in the ground state E1. And as we all know, whenever some external energy is applied on this electron, which is at the valence band, it absorbs the part of the energy and it get excited. It moves from the valence band to the conduction band, or can say it moves lower energy state to the higher energy state. Here I am denoting the state E1 as a lower energy state and E2 as a higher energy state. Now I am applying the sum mean of the energy. This energy may be the heat, light, current, and voltage. So whenever I apply some external energy to this electron, or this electron will excite and moves to energy state E1 to energy state E2. After absorbing the energy, this is called the absorption process. Now, when electrons reaches at the energy state E2, it creates the vacancy or the hole at the low energy state. For the proper understanding, here I am making a hole. Now, what happened to with this electron? This is the nature of an electron. Whenever it moves from valence band to the conduction band, so it will stay there for the only time period of the 10 to the power minus 8 second. So for the 10 to the power minus 8 second, this electron will be stay there, and whenever this time period will complete, it again wants to fall down and want to recombine with these hole. So whenever electron and holes get recombined, here recombination is representing by this bubble and this dot. So whenever electron and holes will recombine, it will generate an energy in the form of the h nu. If it is a LED material or the laser material. So this is a spontaneous emission. Now, in this diagram, where a stimulated emission will take place, there is a basic difference of the direct band gap semiconductors and indirect band gap semiconductors. Whenever electrons directly fall down from the higher energy state to the lower energy state, so this is called the direct band gap semiconductors, because there were no metastable state will available. But in a laser material, whenever electrons get absorption or get the energy from an external mean, it will move to the energy state E2, will create a hole here. At the time period of 10 to the power minus 8 second, it will fall down. And it will stay for the longer time period at the metastable state. So can say after getting the absorption, n numbers of electron will stay at the metastable state. Here it is clearly seen that the population of the electron is very higher at the metastable state. They escape at their native place at the valence band, they move to the conduction band, and they are accumulated at the metastable state. So these processes where the numbers of electrons get accumulated at the metastable state is called the population inversion. This is a very important terminology here to understand the lasing action. So the n numbers of molecules which are present at the metastable state at any time, it's called a population inversion. Now we again required external photonic energy to fall down these electrons. So now I have to supply or give this external Hν energy to these electrons. This is called the pumping energy. Now this is a three level laser, where the first state is the valence band or the low energy state. E2 represents the conduction band, high energy state. E3 is the metastable states. Now if I am again providing some photonic energy to this electron, these electron will fall down. And they will recombine with the holes. And as we know, whenever electron and holes get recombined, it will generate the photonic energy, Hν. This is called the stimulated emission, where these Hν energy and these Hν energy will propagate in the same direction. It will have the same group velocity. That's why the strength of these photonic beam will be the very higher in comparison of the non-coherent optical source. What is the name of the non-coherent optical source? That is the light emitting diode. So I think this topic is very clear to everybody. Now I am going to discuss about the various types of the laser. So I'm roughing this. Types of laser. Lasers are of three types. Solid state laser, semiconductor laser, and the gauge laser. Solid state lasers are the ruby laser, semiconductor lasers are the PN laser, and the gauge lasers are the helium neon laser. So in this lecture we will understand the solid state laser, that is the ruby laser. Ruby laser is also called a crystal laser or the solid state laser, which is manufactured by the Al2O3 and Cr3. Aluminum oxide is doped with the chromium impurities. This artificial ruby crystal is manufactured by the aluminum oxide, which is doped with the chromium molecule. So I'm going to draw the structure of the ruby laser. This is a generalistic diagram of a ruby laser, where a glass tube contains the ruby laser, which is manufactured by the aluminum oxide and which is also doped by the chromium molecule, and a flashlight is introduced to give the photonic light to the ruby crystal. Here, these are two important terminologies. The first one is the optical resonator, and second one is the self emission. Optical resonators are the resonators which uses the self-emitted electrons to make the stimulated emission, and which is the causes of the laser beam. To make the optical resonator, we'll use two mirrors at the left hand side and the right hand side. The left hand side mirror is the completely polished, and right hand side mirror which is also called the mouth of the laser, from which the optical beam will escape. So it is the partially polished. It is generally happens whenever electron get excited from valence to conduction band, and whenever it return back, so it generate the photonic energy. Or sometimes these photons is emitted by the self-emission process. So those electrons or those photonic light which is generated by the self-emission process is reflected by these left hand side mirror and stimulated the another electrons. And those electrons who are available at the metastable state will get excited and fall down after getting the photonic energy by the self-emitted photons. So this is also happens in the ruby laser whenever we apply the flashlight by means of the battery. This flashlight passes through the ruby crystal where aluminum molecule get excited. So the aluminum molecule which are present at the ground level, after getting the absorption energy by this flashlight, will go to the conduction band. Same at the 10 to the power minus 8 second, it will stay there. And will fall down at the metastable state. Now, those electrons who get the population inversion at the metastable state, now they required to get energy from the external mean. So this energy is self-reproduced by the self-emitted photons. These photons will reflect back by these mirror and stimulated these electron. So these self-emitted photons h mu will excite the electron and it will fall down. This electron will this electron hole recombination will generate a photonic energy as we previously understand. So this is the generalistic characteristics and the working of the ruby laser, where Al2O3 material is used for the lasing action and the chromium molecule is doped. Flashlights are using to generate photons for at the absorption process, and molecule of the Al2O3 will excite from the lower state to the higher state. So this is called the solid state laser, and it uses the self emitted photons. Thank you guys. The topic is completed here, and in the second lecture I will complete the helium neon laser. Thank you.